Hi guys, this is Fishers Academy, East Tambaram, Chennai, and today we are helping you guys with a data science course. Yes, first the basic of data science is always statistics, and we are here for you guys and uploading statistics data and basic of statistics.
Good evening, dear friends. We are from Fishers Statistical Academy, Chennai. There are lots of statistical course, online course, and data science course is available. But this is prepared by a statistician who is a scientist and having the background of PhD from Loyola College. So definitely it will be useful with lot of medical applications for the data scientists, those who doesn't know statistics, those who knows the statistics. Definitely it will be a enjoying fun, and also you will learn lot of in-depth statistics. It will definitely useful for your data science activities and big data analysis by R, SAS and other softwares. First I will talk about basics of statistics. It is easy to lie with statistics, but it is hard to tell the truth without statistics. Andrej Drunkus, he told. Next slide. These are the different topics I want to cover in this. First, introduction, then types of statistics, then definitions, then variables and types, then variable scales and description of data, distribution of sample and population, measures of center, dispersion and shape, properties of normal distribution, testing hypothesis, types of error, estimation of sample size, various tests to be used, central limit theorem, parametric tests, t-test, ANOVA, post hoc correlation and regression, non-parametric tests, and tests for categorical data. Summary of tests to be used, qualitative versus quantitative data research, and qualitative research, and software packages that are available. Next slide. Statistics consists of a body of methods for collecting and analyzing data. It provides methods for design, planning and carrying out research studies. Description, summarizing and exploring data. Inference, making predictions and generalizing about phenomena represented by data. Types of statistics. There are two types of statistics. One is descriptive statistics, another is inferential statistics. The first one, descriptive statistics, consists of methods for organizing and summarizing informations, which includes lot of graphs, charts, tables, calculation of average, percentiles. And inferential statistics, it consists of methods for drawing and measuring the reliability of conclusions about population based on information obtained. Includes point estimation, interval estimation, hypothesis testing. Both are interrelated. Necessary to use methods of descriptive statistics to organize and summarize the information obtained before methods of inferential statistics can be used. Next, population and sample. What is population? It is the collection of all individuals or items under consideration in a statistical study. Sample, it is the part of the population from which information is collected. Suppose, for example, I want to find out a university and their course details and other thing, and also find out one survey. For that I cannot take all the University of India. That is our population. For that sample, we will collect 3 to 4 University of Tamil Nadu using simple random sampling methods. Population always represents the target of an investigation. We learn about population by sampling from the collection. Parameters used to summarize the features of the population under investigation. Statistic, it describes a characteristics of the sample which can then be used to make the inference about unknown parameters. Variables and types. Variable, a characteristics that varies from one person to or thing to another person. And types, qualitative, quantitative, discrete, continuous, dependent, independent. Qualitative data, the variable which yield on non-numerical data. Example, sex, either male or female or transgender, like that. And marital status, married, widow, like that. Unmarried. And eye color, there are difference of color. And quantitative data, example, height, weight, number of siblings, the variables that yield numerical data. Number of siblings also numerical data. Next is discrete variable. The variable has only a countable number of distinct possible values. Example, number of car accidents, number of children. Then continuous variables. The variable has divisible unit. Example, weight, length, temperature. Then independent variable. Variable is not dependent on other variable. That is called age, sex. Then dependent variable depends on the independent variable. Example, weight of a newborn or stress, postnatal stress of a woman. So everything is depending on the independent variable. Variable scales. Variables can also described according to the scale on which they are defined. The nominal scale, the categories are merely names. They do not have a natural order. Example, male, female, yes, no. Suppose if you are having diabetic, means yes, no diabetic means no. This is called nominal scale. In ordinary scale, the categories can be put in order, but the difference between the two may not be same as other two. Suppose I am having a disease, I want to know if it is mild, moderate, severe. There are 3 categories. Then automatically it is having order, because severe is having chronic disease, it is a severe in nature. Mild is somewhat, it is very close to normal, that means better than normal, then it is a starting stage of the disease. So moderate is the middle stage of the disease. Automatically it is in order, so it is called ordinal scale. And interval scale. The differences between variables are comparable. The variables does not have absolute zero. Example, temperature, time. Ratio scale. The variable has absolute zero as well as difference between variables are comparable. Example, stress using PSS, insomnia using ISI. It is a ratio scale. And nominal and ordinal scales are used to describe qualitative data. Interval ratio scales are used to describe quantitative data. Describing data. Qualitative data, example, frequency, number of observations falling into particular class category of the qualitative variable. Frequency distribution, table listing all classes and their frequencies. Graphical representation, pie chart, bar graph. Nominal data best displayed by pie chart. Ordinal data best displayed by bar graph. Quantitative data can be presented by a frequency distribution. If the discrete variable has a lot of different values, or if the data is a continuous variable, then data can be grouped into classes categories. Class interval
Good afternoon,
covers the range
friends.
between maximum and
This
minimum values.
is our
Class
second
limits
continuation
endpoints
of
of a
introduction of
class interval.
statistics.
Class of frequency,
This is I'm
number
going
of
to talk
observations
about
in the data
population and
that
sample
belongs
distribution.
to each class interval.
What is
Usual
population distribution? Frequency distribution of the population. Sample distribution, frequency distribution of the sample. Sample distribution is a blurry photo of the population distribution. As the sample size increases, the sample distribution becomes closer representative of the population distribution. Sample of population distribution can be summarized by describing its shape based on the graph. It can be symmetric or non-symmetric, skewed to left, right, based on its tail. This is here graphical representation, properties of numerical data and measures, central tendency and dispersion and shape. Central tendency means mean, median, mode, and dispersion range, interquartile range, standard deviation, and shape, skewness, kurtosis. We'll move on to next slide. Measures of center. Center tendency mean sum of observed values in a data divided by the number of observations. Median, observations in the data set that divides the data into half. Suppose if your data is not belongs to normal distribution, parametric, then we have to see the median value. Median observation in the data set that divides the data set into half. Mode, value of the data set which occurs with greatest frequency. Mean and median can be applied only to a quantitative data. Mode can be used either to qualitative or quantitative data. What to choose? Qualitative variable mode. Quantitative with symmetric distribution mean. Quantitative with skewed distribution median. An outlier. Observation that falls far from the rest of the data, mean gets highly influenced by the outlier. We use sample mean, median and mode to estimate the population mean, median and mode. Measures of dispersion. Dispersion. It is spread variability of values about the measures of central tendency. They quantify the variability of the distribution. Measures include range, sample interquartile range, standard deviation, mostly used for quantitative data. Range, difference between the largest observed value in the data set and the smallest one. So, while considering range, great deal of information is ignored. Interquartile range, difference between the first and third quartiles of the variable. Percentile, divides the observed values into hundreds, 100 equal parts. Deciles, divides the observed values into 10 equal parts. Quartiles, divides the observed values into 4 equal parts. Q1 divides the bottom 25% of the observed values from top 75%. Standard deviation, it is a kind of average of the absolute deviation of observed values from the mean of the variables. So here we can find out how much deviation from the mean of the particular variable. It is defined using a sample mean, and the values get strongly affected by few extreme observations. Shape, skewness, lack of symmetry in the distribution. It can be interpreted from frequency polygon. Properties, mean, median and mode fall at different points. Quartiles are not equidistance from median. Curve is not symmetrical but stretched more to one side. Distribution may be positively or negatively skewed. Limits for coefficient of skewness is plus or minus 3. Kurtosis. Convexity of a curve gives an idea about the flatness, peakedness of the curve. Normal distribution. Bell-shaped symmetric distribution. Why is it is very important? Many things are normally distributed or very close to it. It is easy to work with mathematically. Most inferential statistical methods make use of properties of the normal distribution. Mean is equal to median is equal to mode. 68.2% of the values lie within one standard deviation. 95.4% of the values lie within 2 standard deviation. 99.7% of the values lie within 3 standard deviation. Test to check normal distribution. Checking measures of central tendency, skewness and kurtosis. 2. Graphical evaluation, normal plot, frequency polygon. Statistical tests. Kolmogorov-Smirnov test, Shapiro-Wilk test, Lilliefors test, Pearson chi-square test. Shapiro-Wilk is the best power for the significance. It is if normally distributed, correction of transformation by the data, we are using log transformation. That means if a distribution, if a continuous variable is normally distributed, so it is not a parametrical, then we will do, there are 2 transformation. One is called log transformation using log values. Another is square root of the variable. That continuous variable will be square root. Then that particular variable will be formed. That is called square root transformation. My dear friends, I will tell you, this is an overview of the introduction of statistics. Because data science needs a total package of statistics. I don't want to give very simple. This is I am giving only overview. Normal distribution I am going to take a separate chapter, because it is a very very important one. Normality checking, before that you should know what is normal distribution. That will be taken as a special another chapter. These are the things only I am giving basic. Like that I am giving for hypothesis testing. The aim of doing of study. I want to do a study. What is your aim? Is to check whether the data agree with certain predictions. These predictions are called hypotheses. Suppose I am having 100 data with respect to diabetic patients. All the patients details data, all the parameters obtained from Government Kidpark Medical College Hospital, Diabetic Department. So, my vested interest, what is my hypothesis? First, I will see the prevalence of peripheral neuropathy, one disorder with respect to foot of the patients. Those who are having diabetic will have lot of disorders. This is the theory. So, based on this medical theory, as a researcher, I want to know first prevalence of peripheral neuropathy and what are the associated risk factors with respect to peripheral neuropathy. Here one hypothesis, first I am going to see duration of diabetics. So my hypothesis is there is no statistically significant difference between peripheral neuropathy and no peripheral neuropathy with respect to the duration of diabetics. Suppose duration diabetes increases or lesses, it is not a factor. This is my null hypothesis. Significance test. This is an example. Detailed example will be given here and there when I am going to take all the hypothesis analysis and separate chapter will be there. So that time I will give lot of medical and non-medical examples so that you can understand and you can apply in your practical life, dear friends. And significance test. It is a way of statistically testing an hypothesis by comparing the data values. It consists of 2 hypotheses. One is called null hypothesis, that is always denoted as H naught. Another is alternative hypothesis, that is always noted by H1. Null hypothesis is usually a statement that the parameter has value corresponding to, in some sense, no effect. Alternative hypothesis is a hypothesis contradicts the null hypothesis. It is opposite to our null hypothesis. Alternative hypotheses are formulated before collecting the data. Significant test analyzes the strength of the sample evidences against the null hypothesis. The test is conducted to investigate whether the data contradicts the null hypothesis, suggesting alternative hypothesis is true. Okay, previous our example, diabetic patients with peripheral neuropathy. So duration of diabetes is a continuous measurements. So here the test one, for example, here in this example we are using student street test because two independent samples. One is peripheral neuropathy, some 20 patients, no peripheral neuropathy, some 80 patients, 20 patients of the duration of diabetics and 80 patients. So there is a continuous variable. We are using T statistics, student street test statistics. The test is conducted. For what purpose they are conducting? We are conducted the test to investigate whether the data contradicts the null hypothesis. What my null hypothesis says, there is no statistically significant difference of peripheral neuropathy and non-peripheral neuropathy with respect to duration of statistics. Suppose my probability value is greater than less than 0.05, then automatically I am contradicting my null hypothesis. I am saying that my null hypothesis is false. My alternative hypothesis, that means there exists a statistically significant difference between the duration of statistics mean with respect to peripheral neuropathy and non-peripheral neuropathy patients. Okay. This is the for investigation. So detail will be there. Here I am giving an example to understand our introduction of statistics, overview of statistics in a better manner. Then only you will have interest and you look to all my totally I'll have more than 30 or 40 videos. That means YouTube videos will be uploaded. That we don't know. But whatever it is, next time I am going to tell about p-value and other thing in my next chapter. Thank you. Bye. Good day. Ram Ram. Jai Ram. Good evening, friends. Now in continuation, we have to see the probability value. P value is the probability if H naught means what is null hypothesis were true, that the statistics test would fall in this collection of values. The smaller the p-value, the more strongly the data contradicts H naught. When p-value less than or equal to 0.05, data sufficiently contradicts H naught. Why probability value is less than 0.05? It is $1 million questionnaire arises for all the postgraduate students of medical, non-medical and all people, because here our level of significance, that is alpha, is 95% or 0.05. So 95% means 0.95. So 1 is equal, 1 minus 0.95 is equal to 0.05. Suppose our level of significance is 0.01, otherwise 99% of confidence, then automatically our probability value will be less than 0.05. But default, most of the medical journals, they are following less than 0.05 because they are taking assumption alpha is equal to 0.05 or 95% confidence interval. They are applying, they are assuming. Okay. The next type of error. Type 1 error, rejecting true null hypothesis, we may conclude that difference is significant, when in fact there is no real difference. It is popularly known as p-value. Maximum p-value allowed is called as the level of significance. Being serious p-value is kept low, mostly less than 5% or p is less than 0.05. Type 2 error, accepting false null hypothesis. we may conclude that difference is not significant when in fact there is a real difference. It is also called as power of the test and indicates sensitivity of the test. Not possible to reduce both type 1 and 2. So alpha error is fixed at a tolerable limits and beta error is minimized by increased sample size. Estimation of sample size. Small sample fails to detect clinically important effects, lack of power. Large sample identify of differences which has no clinical relevance. Calculation is based on not included formulas. Estimation of mean, estimation of proportions, comparisons in two means, comparisons in two proportions. Checklist. Level of significance, power, study design, statistical procedure. Minimum sample size required for statistical analysis 50. Basic theorem in statistics, central limit theorem, states that distribution of the sum average of a large number of independent, identically distributed variables will be approximately normal. What is this important? Basics of any statistical procedures. What is parametric tests? These are statistical tests that makes assumptions about the parameters, defining properties. Assumptions are made out. Data follows normal distribution. Sample size is large enough for central limit theorem to lead to normality of averages. Data is not normal but can be transformed. Some situations where data does not follow normal distribution. Outcome is an ordinal variable. Presence of definite outliers. Outcome has clear limits of demarcation. Test to be used. Suppose I am having scale, that means data type, scale type, nominal, and permissible statistics is mode and chi-square or chi-test, chi-square test. Then ordinal, mode, median, that also chi-square test, that is a non-parametric test. Then interval, ratio, where mean standard deviation can be found out. These are the tests, t-test, students t-test, and analysis of variance, that is called ANOVA, and post hoc. After ANOVA, post hoc comparison, then correlation, then regression. And one sample t-test, independent t-test, and dependent t-test. Compare the sample mean with the population mean. This is called one sample t-test. Compare the means of two independent samples, independent t-test. Dependent t-test, that is called paired samples. Suppose if you are having hemoglobin levels of 100 patients, those who are attending a clinical trial, and the same patients after 1 month giving some intervention of iron tablets, some nutritional food, then automatically fenugreek and other supplementary items also given. Then after that 1 month, again hemoglobin of the same 100 patients will be tested, and we want to find out whether our hypothesis is there any statistical significance difference between pre and post intervention. So for that area we are not supposed to use t-test to sample, because the same patients after follow-up, after intervention tested. So that is called paired pre and post. That is why paired t-sample test will be applied. Analysis of variance. T-test difference between two means. If there are more than two means, that actually we usually used to call ANOVA as a extension of t-test, because in t-test we can do only two comparisons. Suppose if we want two means, more than two means, then going to to the t-test increases the alpha and b error, which creates a serious flaw of the data and analysis. So when there are greater than 2 means to compare, we use analysis of variance types, one-way study effects of one factors, two-way study effects of multiple factors. Assumptions of ANOVA, here also normality and linearity. ANOVA, it is a blend of ANOVA and regression. In other words, measures of how much two variables change together and how strong is the relationship. Latin phrase post hoc means after this. What after the event? That means one event. ANOVA is an event. ANOVA we can find out we have got a statistical significance. Then ANOVA tells whether there is an overall difference between the groups. The groups more than two variables, 3, 4, 5, 6, 7. So, but it does not tell which specific group is differed from other group. So for that, post hoc tests will be there. From that we can see where is the difference occurred between groups. Different post hoc tests. Bonferroni, Fisher's least significant difference LSD, Turkey's honestly significant difference HSD, Sheffield post hoc tests. Correlation and regression. Correlation denotes association between two quantitative variables. Assume that the association is linear, that is, one variable increases or decreases a fixed amount for a unit, increases or decreases in the other. Degree of association is measured by a correlation coefficient R. R is measured on a scale from -1 through 0 to +1. When both variables increases, then R is positive, and when one variable increases and other decreases, then R is negative. Graphically, scatter diagrams, usually independent variable is plotted against x-axis and dependent variable against y-axis. Limitation, it does not say anything about cause and effect relationship. Beware of spurious and nonsense correlation. Correlation, it is a strength or degree of association. Regression, nature of association. Example, if x and y related, it means if x changes the certain amount, then y changes on an average by certain amount. Expresses the linear relationship between variables. Regression coefficient beta, types linear and non-linear stepwise. Regression coefficient gives a better summary of the relationship between the two variables than correlation coefficient. Non-parametric tests, also called as distribution free tests. We usually used to call distribution free tests because they are based on fewer assumptions. Advantages, when data does not follow normal distribution, when the average is better represented by median, sample size is small, and presence of outliers, relatively simple to conduct. Tests. Actually, previously we have seen one table there. Actually, what are the situation? What is the parametric test? Now, actually, I am giving a situation characters, and I am telling what are the parametric test, what is the non-parametric test. Suppose if your data, continuous data is following parametric, that means following normal distribution, then automatically testing mean and hypothesized value one sample t-test. There in non-parametric, that means non-normal distribution, we are following sign test. Comparison of means of two groups, independent t-test. Whereas non-parametric test, we will follow Mann-Whitney test, Mann-Whitney U test. And means of related samples. That is, I told you pre and post, that is a related samples. That means the same patients will be taken on lab measures, then after intervention the same patient's hemoglobin level, that is called a means of related samples. The sample is related, so it is not independent, so then we are going for pair test. Same thing, that particular pair test values are not normal, not following normal distribution, then we are going for non-parametric test. For that equal test, we are used to call as Wilcoxon signed rank test. Okay. Then comparison of means of more than two groups. Usually in our general parametric, we used to call as ANOVA. Same thing for non-normal distribution, Kruskal-Wallis test. Otherwise, we used to call as non-parametric ANOVA. Okay. Then comparison means of greater than two related groups. Repeated measures of ANOVA and Friedman's test. This is parametric test. This is Friedman test for non-parametric test. Assessing the relationship between the two quantitative variables, Pearson correlation and Spearman's correlation. Okay. That is why I have put here one table format, so it will be very easily you can understand and follow while selecting your data variables, which test you can follow. So normally it is I am talking about chi-square test, chi-square. People will tell lot of way, but it is a very most famous non-parametric test for categorical data used for analysis of categorical data. Others test, fixed exact probability test, meas test. Requirements of chi-square: sample should be independent, sample size should be reasonably large, maybe more than 40, because our expected cell frequency should not be less than 5. Each frequency in ABCD, so that each cell should not be less than 5. Yates correction: if expected cell frequency is less than 5, so Yates, one statistician, he has given a new formula for correction for some expected cell frequency is less than 5. He has formulated another formula. And Fisher's exact probability cell used when sample size is small. Suppose greater than 40 we used to go for this, and less than 20 sample size, then automatically it is better to go for not to go for Yates correction and chi-square. It is better to go for Fisher's exact probability test, because our sample size is small, n less than 20. And McNemar test, what is McNemar test? Same thing, it is like a paired t test for continuous variable. For this categorical variable, this is also paired samples. That means, suppose I am observing a view of 100 people, whether they will vote for next time for Bharatiya Janata Party or others. Okay. In 2000, that means 19 January, I am taking the same 100 people. The same 100 people I am taking after 3 months. Okay. The same people, actually we are giving lot of inputs, current affairs, current things to those people. Then after January, I am taking one sample. I am saying some 20 people like BJP and 80 people doesn't like it. And May, after that, I have given some more information, day-to-day live up-to-dates on the same 100 people. So we are doing again survey. Their views is this time some BJP is 80 and this other people 20. Because of the influence of the events that occurred from January to March, January to April, then automatically their likings changes will be there. They are having inclined towards more than one particular party. This is paired. This is not chi-squared. So for this particular situation, we are supposed to go only McNemar's test used when there are two related samples or there are repeated measurements. So any paired samples, suppose 100 persons, those who are having diabetic, whether they are having depression or not, then after 2 months we are giving lot of counseling, other thing. So the 100 diabetic patients, 20 patients they are already in depression, they turned into 18 people turned into again normal. So it is because of the intervention, lot of counseling. So these, for this particular situation, we are not supposed to use chi-square test, and Fisher's exact. We are supposed to use only McNemar's test because this is paired observations. What is relative risk? Very important factor. It is the ratio of incidence rate among exposed to the incidence rate among not exposed, used in random cohort RCT and cohort randomized clinical trial, that is called RCT, and cohort studies. Values less than 1, risk of disease is less among exposed. Value is greater than 1, risk of disease is more among exposed. Is equal to 1, equal risk among exposed and non-exposed. What is the odds ratio? Usually it represents as OR or odds ratio. Ratio of odds of exposure among the cases to odds of exposure among controls, used for rare diseases events. Used in actually relative risk in cohort studies or RCT studies, randomized clinical trial, and odds ratio usually in case control and retrospective studies. No meaning in calculating the risk of getting the disease. Suppose value is greater than 1, more among cases, less than 1, more among controls. Qualitative versus quantitative. Qualitative research seeks to confirm hypothesis. Quantitative research seeks to explore phenomena. And qualitative research, highly structured methods used. Quantitative research, semi-structured methods used. And qualitative research used close-ended numerical methods of collecting data. And quantitative research uses open-ended textual methods. And qualitative research study design is fixed, subject to statistical assumptions, and quantitative research study design is flexible, iterative, and subject to textual analysis. Qualitative research provides complex descriptions and information about issues such as contradictory behavior, belief, opinions, emotions, and relationships. Methods used are phenomenology, ethnography, grounded theory. Designs used case studies, comparative designs, snapshots, retrospective and longitudinal studies. Statistical software packages. Previously, SPSS was with SPSS Inc., one biggest company in US. Now it was acquired by IBM, International Business Machines. So another is R. R is a freeware, R Foundation. It is a freeware and the best software used in all data scientists, all software. And GenSet by VSN International, and Mathematica by Wolfram Research, Minitab, MATLAB, Nemad Statistics, etc. These are the quantitative research. For qualitative research, Atlas-T, Nuvivio, Mascuda, Nudist, Anthropac. Thank you, my dear friends. Herewith I am concluding my first video, that means introduction of statistics. Thank you very much for patiently hearing all my slides, all my inputs. Thank you, my sincere best wishes. We'll see you in the next video session. Maybe probably I'm going to take normal distribution very detailedly. So I'm preparing for that. Within 1 or 2 days I'll come with a new video for normal distribution. Definitely it will be very much useful for any data scientist. All the best. Thank you.